Hello and welcome to the AI Digest. This is a very special episode with Professor Aidan Hogan. Today is actually the 4th of July, and as soon as this is over, I'm going to go get a burger. So I'd love to first introduce a little bit on Aidan. He is an associate professor at the University of Chile and vice director of the Millennium Institute for Foundational Research on Data in Chile. Can you tell us a little bit about what those institutions do and what you contribute to further their work?
Of course, first of all, very happy to be here. Thanks very much for the invitation. So the University of Chile is one of the largest universities, the oldest public university in Chile. So I'm part of the Faculty of Engineering and Mathematics in the Computer Science department. So I'm like an associate professor. I teach classes, I supervise students, I do research now and again, lots of administration, which is no fun. So it's essentially a large university with faculty spread all around Santiago City. And the second affiliation of mine is the Institute for Millennium Institute for Foundational Research on Data. I can actually say it more naturally in Spanish. I'm not used to saying it in English, but so it's essentially relatively large, especially by Chilean standards, research initiative, which brings together 5, 6 universities and essentially funds some of the professors to do research in that topic and tries to get people together to collaborate so they're not just working on their own in their own ivory towers of their different universities. In the University of Chile, I'm in the Department of Computer Science. We have professors in all sorts of different areas. We have professors in software engineering and data and artificial intelligence and computer science theory. In the IMFD, we have a mix of social sciences people, communications people, people interested in machine learning, people interested in more traditional database topics, data structures, databases, and so forth, and knowledge representation as well.
Wow, such a spectrum of technologies and interests. Let's give a little shout out to the research group that you're working with and the new academic journal that is free and open source for readers and authors. That you're gonna have to forgive me. I'm not a native German speaker. Dachstuhl?
Yep,
Dachstuhl?
perfect.
Okay.
Well, I'm not a native German speaker either, so I can't correct you. It could be, but I would say Dachstuhl. So the Dachstuhl publishing is so people who work in computer science, many of them would be familiar with Dachstuhl, which is this castle that is in Germany, close to the border with Luxembourg, where they invite computer scientists to go and spend a week, and you just stay in this castle in the middle of nowhere and you discuss research topics. Which is really nice. I've really enjoyed being there many times. And now Dachstuhl also offers some publishing services for computer science conferences and journals in terms of publishing research. And together with some colleagues, Ian Horrocks from the University of Oxford, Andreas Holte from the University of Würzburg, and Lana McCaggle from the University or the Massachusetts Institute of Technology, MIT. We started a new journal, Transactions on Graph Data and Knowledge, where we're aiming to publish research for free. So no fees to authors, no fees to readers. And it's been going well so far. We have published, I think, until now, about 17 papers. And the first papers were published in December of last year. So we're still new, and invite people to check it out. If they have some research about knowledge graphs, think about submitting it there.
Awesome. Um, I'd love to talk a little bit about your background to sort of lay the context of this conversation. Just to tell the audience, you received your PhD from the National University of Ireland, Galway in 2011. And, we're in 2024 now. Um, so you've been in this space for quite some time, artificial intelligence as a spectrum as a whole. Care to tell us a little bit about what your experience was and what led you to this sort of career path?
Yeah, so I guess many of the people watching and listening might have figured that I'm not Chilean. I don't look like a typical Chilean. I'm Irish.
I'm
I
shocked.
studied quite a surprise. Um, so yeah, I studied. I did my undergrad in Ireland, and I was doing electrical engineering. And then, as an internship, I was invited to work at I was invited to give an interview at a research institute that was in Galway called Derry Galway, working on semantic web topics. So semantic web, this idea of using knowledge representation and data methods to improve interoperability and automation on the web, make the web better. So as an intern, I was just coding things PhD students told me to code, and then I started learning a bit more about their research topics, and then I did my undergrad thesis there, I did my master's, transferred from a master's to a PhD, finished my PhD. So I was really interested in this topic, which had this particular view towards making the web better. There was a very concrete goal behind the semantic web topic, the area. It had this vision of, the semantic web, which we could maybe discuss more later, for example. But I was very interested in that topic, and then I did 2 years of a postdoc in Galway, and then I started to look further afield for opportunities in the academic space. So I started applying to universities, and came to the University of Chile, where there was a strong group of professors working on the semantic web, more from the theory part. But I was actually quite interested in that aspect of strengthening the theory part of my research expertise, let's say. So I came to Chile. Since then, I've been working on more topics. I tried to branch out, so I'm not purely semantic web. I work in a bit in information extraction and databases, like graph databases. Knowledge graphs is this new topic that has emerged. I've worked as well a bit on machine learning, and the more machine learning side of artificial intelligence as well.
I'd love to point out that you've contributed to well, not contributed, you co-authored 3 books to date, including Reasoning Techniques for the Web of Data, the Web of Data, and the Knowledge Graphs. So, as you were talking about earlier, and we will talk about this further in the conversation, you've held quite a number of contributions to this field already. Um, can we talk about that transition from Ireland to Chile a little bit more, and where your focus is right now?
Yeah, for sure. So in 2012, I guess I started thinking I was doing a postdoc. I was doing a postdoc in the same place as I did a PhD. And often that's considered not the best practice, in the sense that you should move and see other things. And I had done my undergrad, my PhD, and my postdoc in the same place. And where I was working had a more research institute feel, where there was a lot of thirst for research funds, because we were all paid from research funds. So we were constantly looking for new projects and looking for new funding, as well as doing research. I was more interested in maybe getting a job at a university. So I started applying and looking for tenure track positions in different places. So I essentially, leaving Galway, I would say I was an expert on the semantic web. That was my key area. That's what I did my PhD in. I did it on deductive reasoning over ontologies and over the web at large scale. And then when I came to Chile, I came also to work with people from the semantic web. But Chile is a little bit different in the sense that the Department of Computer Science here is not that big. There's like 20 sort of full-time professors, let's say, in the largest, let's say the largest public university, at least one of the largest universities in Chile. So you end up kind of rubbing shoulders, let's say, with professors who are working on very different topics to you. So you end up in a much more diverse group, and that started with computer science. You're bumping into people who work in multimedia. You're bumping into people who are really good at compressed data structures. You're bumping into people, and then you get talking with them and you say, hey, let's co-supervise a student, So that's a good way to collaborate between professors. It's like you don't actually have to invest too much work, but you just, and the student has to figure out how to intersect both areas. And that goes well, and then you start to collaborate, and you see different areas of computer science. So that's actually one thing I think is really nice about Chile, that because it's not at the scale of other computer science departments in let's say North America or in Europe, for example. Because it's at a smaller scale, you actually end up having a more diverse set of collaborators. I know at the Millennium Institute, now it's not just computer science. We rub shoulders with people from communications, people from social sciences who are trying to understand social phenomena in Chile. So we get an aspect, it's not just the technical aspects as well, but also some idea of what the applications could be, but also what are some of the challenges of, let's say, artificial intelligence or applying automated methods to try to understand political situations, for example.
That sounds like a healthy ecosystem with lots of dueling of ideas and perspectives. Um, I would like to just take a brief moment to sort of walk back and define some of these technologies because you've addressed quite a spectrum of technologies just in the first 10 minutes of this discussion. Uh, you've mentioned database, deductive reasoning, knowledge representation, the semantic web, data as a concept in itself. Uh, how would you go about defining some of these terms and then composing them together to paint a picture of the space that you're in?
Yeah, I think that could be challenging, but it starts, I think, there's a lot of things we mentioned. It's probably an undergrad course, an undergrad degree to understand all these concepts in depth, but we can definitely cover them at a high level. No? So I think it all starts with data. Essentially, data is basically, you have all these sorts of sensors, or you have cameras that generate data, you have thermometers that generate data. And we as humans as well are somehow sensors because we're going around interacting with the world and typing in our keyboard, typing on our phones, some observations or some data about what we're observing or what we're living. So it starts with data. You have a bunch of zeros and ones on your machine. And then the question is, how do you start to make sense of that? So the first thing you want to do is you might want to do queries. So if you're working in a bank, you might want to query how much money does this client have, because they're asking to withdraw $1,000 and we need to know if they actually have $1,000 or not. So you have all this data sitting on your hard drive. How do you format that data so that you can actually do queries, like to find out what are the amounts in different clients' bank accounts. In this comes databases. A database is essentially a structured way of formatting your data so you can access the data you need when you need it efficiently. And this is what powers, we all, I do this typical thing. I'm a database professor. I do this typical thing in the first class in databases. I ask all the students, how many people have you here used the database? And nobody puts up their hand. Maybe one person puts up their hand. And then I convince them all during the first class that all of them have used several databases that day, because every time you go online, you use a database. Every time you use they have to use a key card to get in. That's a database that's being touched. Every time you buy coffee, it's all generating data that goes into this database, this structured form. So then there's the question of, okay, let's say we have different databases in different places on the web, for example. How do we get them to talk? And also, what do we do with the massive amount of data that's not in a database? It's just text. It's just, there's no structure to it. It's not, in tables. It's not structured in some way. It's just a bunch of text of natural language, as people call it, English, Spanish, whatever it might be. What do we do with that? What do we do with images? What do we do with the videos, right? What can we do with these? And then how can we interoperate? So let's say we have two banks. Even if they have structured databases, how can they talk? Let's say you're a patient, you're ill, you're in a different country. You go to the hospital and they would like to know what your history is. What's your medical history? They could ask you, but often patients are not the most reliable conveyors of their medical history. It would be great if they could pull. Obviously, this creates problems with privacy and security and so forth, but it would be ideal if the healthcare professionals where that patient was could pull the data, the history of that patient from another hospital. But how to do that if you haven't already coordinated how to structure, you'll end up with completely different structures that don't interoperate. And then that comes into the area of knowledge representation, ontologies, where we essentially agree on definitions of terms of what it means to be ill, what it means to have a cold or a flu. What are the different types of diseases and how they interact and so forth, and trying to get people to agree with those so that if they agree to that, then we can exchange data between these different places. And then comes the sort of AI revolution, or the machine learning revolution, or the deep learning revolution, or the large language model revolution, which is, well, we don't need to put all this effort into structuring and defining things. We can just heap everything, apparently, into a bunch of GPUs and create these very, very large models that have a bunch of zeros and ones that can magically produce the answers we need.
For someone who was hesitant to take the challenge, you did that fairly well. We capture observations about the world in data in human and machine understandable ways, and we structure that data in a way that we can reproduce questions and answers throughout time, and we find ways of further modeling the knowledge of humans in a way that machines can interpret that, so that we can extend our reasoning capabilities to machines. And there's all these sorts of permutations of those technologies: machine learning, or statistical AI, and symbolic AI. So I think that was a beautiful summary of the intro course. So anybody listening, if you want to present this as your first 9 to 16 credits in your computer science degree, feel free to try. Uh,
Well, take the transcript through ChatGPT first. Take the transcript, and they'll tell ChatGPT to make it better, and then submit that.
Pro tip. So I'd welcome the idea of talking a little bit about these different kinds of artificial intelligence. And you said that there are multiple revolutions, multiple waves of innovation that have come throughout the years, and you've been around and as a PhD, as a postdoc, 13 years now. So you've seen quite a bit of hype, crypto and blockchain, and deep learning and all these things. Um, can you explain what are the differences between the two major thoughts of AI, statistical and symbolic?
Yeah. So, I mean, AI now, people would think, if you ask people on the street, when you talk about AI, they might think about self-driving cars. They'll think about ChatGPT. They'll think about the AlphaGo. These sorts of very household things. Most of these are driven by sort of statistical or neural AI, which is essentially, it was inspired by the brain. So it has its foundations from probably the 50s, where people started to think about developing a sort of neuron or perceptron that could somehow emulate how our brain works, where we have neurons that somehow connect and they light up and they fire messages to each other. And this eventually led to neural networks, and then adding lots of layers kind of led to deep learning, and it kind of leads us to where we are today. Actually, the revolution, let's say, or the advances we've seen in this sort of statistical AI, the techniques have been more or less known for quite a long time. The big difference is now we have a lot of data. Of course, there's been, I don't want to say there's not been any advances. There has, but more refinements of techniques. The main jigsaw pieces were in place for the likes of ChatGPT, for the likes of AlphaGo and so forth. The big difference now is the hardware, that you can sort of train these very large models. And this idea as well that was kind of new, which was the deep learning, which started maybe with AlexNet for image recognition, that somehow just adding a bunch of layers and a bunch of data is extremely effective. It works much better than anybody would have anticipated, which wasn't really understood for a long time. Even though all the ingredients were there to do it, it was sort of a discovery almost that, this leads to good performance. So, having these, if you think about, if you're modeling a brain, you can have a very small brain, maybe with, 10 neurons in there. But what we're doing now is having much larger models, and these seem to be capable of excellent performance in what we would call tasks, like find the images that show a dog, or generative AI as well, for example, for ChatGPT, generate some text. So that's the statistical part, and that's what people would probably think of now in AI. But AI even in its tradition, has been mostly focused more towards the symbolic aspect. Sometimes they were in parallel, sometimes the symbolic aspect was more emphasized in the AI community, sometimes the statistical part came to the fore. So the symbolic side is this idea that the classical way would be to look at natural language text, right? Just English, Spanish text. So people were very interested from the outset of AI in understanding text, using machines or using computers to understand text. So if you think of a benchmark of intelligence of human, and we have a human perspective of intelligence here, right? When we say this sort of thing. So when we think about intelligence, we would associate this maybe with understanding text, language, how we communicate. So the classical way, the way it was originally attacked this problem of getting machines to be able to understand text, you give them maybe an encyclopedia page, and then you ask it questions about that page, about the content of that page, and then it gives you answers. They wanted to achieve this sort of thing, or that you could have a conversation with the machine and it would seem somehow human. The way they addressed this originally was through rules. They thought that human language must have some sort of inherent structure, and we can parse it down into subject, verb, object, adjective. We can build a structure around text, and then we can start to build a higher level structure across sentences. For example, the he in this sentence referred to the John that we saw 2 sentences back. And we could do all of this just using rules. Yeah. So if we see he, then we should go back to the last proper noun that we saw, unless in this case, we should, these sorts of things. But these rules could only scrape the surface of the complexity of natural language, of how people speak and understand language. So essentially, at the same time, there's this knowledge representation side, which started to think about, okay, we have this natural language understanding or processing problem. We can attack it with a statistical way. We could attack it with a more symbolic way. There is another movement towards more knowledge representation, which would be, for example, okay, machines aren't very good at understanding natural language, what we normally speak in. So how about we create formats that machines can understand? What does machine understandable data or content or information look like? So then this deals with the classic symbolic approach would be to assign symbols or IDs or names to things that are unique and that are ideally one-to-one. So let's say I assign a symbol to the University of Chile. It could be, for example, just a code like Q12345. If people know Wikidata, they have these numeric numbers, which is a knowledge graph. They use these numeric IDs like this. So we have some sort of symbol. It can be a sequence of characters, whatever it is. And then it relates somehow to other things. So we know that it's in Santiago. So we can create another symbol for Santiago, and then we could connect these two ideas to say University of Chile is located in Santiago. What's this idea of symbols? The idea of symbols there is just that machines don't actually understand what a university is. They have no idea what Santiago is. Yeah, that's not their way. But somehow, if you teach these algorithms certain rules, you can get them to manipulate symbols such that it seems like they know what's going on, although they have no idea. Yeah, this artificial intelligence again. So let's say a classic thing would be, you could say, for example, if the University of Chile is located in Santiago and Santiago is part of Chile, then we could infer, for example, the University of Chile is located in Chile as well. Yeah, so we can create these things, and it doesn't really matter. We don't need to know what a university is. We can use these sort of logical arguments, and we can use symbolic methods, for example, to apply logic to data, to structure the data and apply logical methods over it. So this would be the deductive reasoning I mentioned earlier. So there are these, maybe going back to a more high level, there are these two factions within artificial intelligence. There is the very precise, logical, controlled, explainable, transparent, symbolic approach, where you can really look inside and you can see, oh, I got this answer, or I got this result, or this came out because of this logical process that I can follow. Maybe it might be difficult to explain, but it's all there. Deterministic as well, versus the more imprecise, the more messy maybe, but the more more human-like, I would say, statistical AI. Yeah, so the statistical AI can do things that seems much more human to us than what symbolic methods can currently do. In the sense that when we see it, create an image, or when it gives us text, it just seems somehow to have this human-like quality to it. But we know, as many people use ChatGPT, will have countered that we can't rely on its precision. And it's also very difficult to explain why a particular result was given, because what's behind that is essentially a huge number of parameters, a big black box of numbers, of statistics, basically.
Wonderfully explained. So statistical, we have used machines throughout time as calculators to compute complex equations and layer logic and all these sorts of operations. And that power has only grown as we've unlocked or developed new hardware capabilities, right? Whenever we develop new architectures for computer chips, or ways of fitting more transistors on one chip and making things more potent with GPUs and CPUs and all the PUs. Um, it's that's the exercise there, and that is all statistical. Like the algorithms behind all those kinds of computations are all based on mathematics. But then you said also there is the way that we've been communicating within language, people to people within the written language, the symbolic artificial intelligence or symbolic interpretation of what we perceive to be reality, right? The hieroglyphics in Egypt, each symbol carried a meaning, and we as wet machines, wet with our wetware, were able to assign a value to a buffalo or a cow or a chicken, and we knew, okay, count how many chickens there are. Here's what I'm giving you, and here's the exchange of barley. But now we're able to take these ideas that we share through text with each other and find some sort of social technical contract through machines where we can share a meaning in an abstract manner. So that's the potency of that we can bake our understanding of the world and agree to certain symbols to represent certain ideas in the world and certain business rules, or just rules of how the world works, where then machines can take over and perform computations or reason on our behalf. Is that correct?
Yeah, I think that captures it really well. I think what we're good at as humans, we're good at learning, at adapting, at communicating, at this sort of evolutionary aspect of evolving language. What we're very poor at is doing repetitive things, doing things precisely, doing things at large scale. Which is what machines are great at. So it's somehow we're trying to somehow find this way where we can encode more of the world in such a way that we can get the machines to do the stuff we're bad at. And if we look at the web, that's a classic example where nobody's going to read all the web. I'm not, no one human has the time to read all the web, and they would not even remember in any case, what they read, maybe even the day before. So we need machines to be able to have this sort of like some global repository of information like the web, and then we need to figure out, okay, yeah, so we can just publish documents that, for other humans to read, and then we can share them. We can use machines to share them, but maybe machines could help us do more in that setting. If we could somehow encode some of our understanding or some of the way we see the world, if we could pass that on to machines, then machines could automate more and more tasks for us, and they could do it at a much higher scale and precision and much more efficiently than humans could do it. So I think then it's a question of, okay, how do we, in some sense, of course, we use all these words of intelligence and teach and so forth in the context of machines as analogies, because we don't have good words for for this, but how do we teach machines more of our perspective of the world so that they can reason about what they, let's say, what's on their hard drive, what's on the web, so they can reason about it automatically on our behalf. Yep.
I appreciate you saying that there are constraints in people and there are constraints in machines, and we are trying to find ways to compensate for our respective shortcomings by integrating in some mutually beneficial way. Although the benefit always goes to humans. The
Yeah.
machines are just inert physical objects in this scenario, and always,
Mm,
you don't have Wally with emotions in the picture here.
mm,
Um, I mean, you come to this world, you download the local language, the local cultures. Your parents teach you more morality, ethics. Your teachers teach you how to survive. You go to college, you pick your life path, you find your profession. If you don't document your knowledge in books or pass it on to other people when you die, that knowledge is gone. So,
mm.
being able to preserve our knowledge and consolidate that in one fixed point that can help other people survive or develop better systems, better tooling. I think that's the way that the internet has served, right? As a intermediary for people to preserve their knowledge, experience, etc.
Yep. So in general, with the internet, with the web, it's still, though it's essentially like a way of storing documents. There isn't much more beyond that. Let's say with the web, you put up a web page, and you put that web page up so that other people can read it. You're not putting it up so that machines can read it, right? So, which is fine. So what the machines will do is you look up some URL, you put it into your browser, it goes to some web server somewhere. Your browser contacts the machine behind that server, asks for the page, retrieves the page, and displays you the page as it was intended to be seen. And it's not doing much more than that. It's just fetching the pages for you, and then you read the pages. The machine that serves the page, now those machines have gotten a bit more, the server side have gotten a bit more sophisticated with time. It used to be that you would publish what's called a HTML page, which is just a text page with some rendering or formatting instructions, and it was static. You would just store it and it would be served. But now on the servers, you can enter some details. I want a flight on this date, and that goes to the server, and the server actually calculates somehow the content for your pages dynamically. But still, the delivery mechanism is still the same. You get this document back. Yeah. So capturing all this sort of information, like capturing all of the knowledge, is great. It's great just to have it written down. It doesn't matter if it's chiseled on a stone. It doesn't matter if it's. But there is somehow a hierarchy for what would be the best ways to capture human knowledge to make it more reusable. Yeah. So we could say, maybe the base, we could take an arbitrary base, but we could say the base here, we could assume it to be a stone tablet. Yeah, we chisel some stuff into a stone tablet. It's kind of awkward. It's heavy to bring around. People have to probably go to see it. You won't be able to bring it around with you. And then you could say, okay, well, you could write something on a paper. That paper you can maybe show it. You can at least bring it around. It's portable. And then you can say, okay, well, we could store it as a sort of book, with a printing press, so we can replicate or we can reproduce this and send it out to different places, and so on and so forth. And then you could get to the web where we are now. But the main issue with the web, where now we can very easily share documents. We can, we have some sort of reliability. We know that the documents, well, if we keep our web server up or if we publish them in a well-known website, we have some high confidence that they'll be around for a while, that they're easily transportable, that you can be easily shared and exchanged. The main problem we have with the web at the moment in this way of capturing our human knowledge is that if we want to integrate somehow the information of 2 or 3 or 4 pages and come to some conclusion, it has to be done by a person more or less. Or one could argue now a large language model, maybe ChatGPT can do something of that for us, but not with the high level of precision. So I think with the emergence now of, I would have said, 5 years ago, that the best way to capture human knowledge would be through knowledge representation principles, which goes to the symbolic way, where we have some sort of precise, formal specification of what we mean. Where when we talk about astronomy, let's say, what is a star? What is a planet? What does it mean for a moon to be a moon? These sorts of things. And we have this for all the domains that matter to us. Maybe not, it's costly, so we're not going to cover all of the world's knowledge, but at least we're moving towards that direction and capturing knowledge that way. 5 years ago, I would have said that was definitely the route forward. Now I'm less certain, because it seems that just these large language models, these foundational models, seem to also be able to do this sort of integration, interoperability, taking stuff from all these different places and piecing them together. But ChatGPT is surely fallible, in the sense that it's a question of what's the limit of this technology. So yeah, it's a question of what's the best way to encode this human knowledge. And I would say what you mentioned is interesting in terms of morals, for example, that are passed on from parent to child or from community to member. Those sorts of things are impossible or are very difficult to capture with symbolic methods. Whereas ChatGPT, if you ask it sort of moral questions, sometimes it seems to be able to give a reasonable answer that's obviously a synthesis of lots of text it's seen. So yeah.
So if we follow in that perspective that you outlined earlier, man, we got real tired of chiseling rocks and carrying them on our backs. I mean, we were jacked back in the day. Now we're wimpy because we were carrying little laptops. But we underwent several information revolutions, which made it more efficient for us to and document and share our knowledge at scale, and also increase the rate at which we can consume and share that knowledge, from rocks to papyrus, paper, whatever, to books and uh, printing, the typewriting machines that allowed you to fully form. So typewriters, and then we found ways of storing things in disks and computer chips, et cetera, et cetera. I mean, there's just all these different modalities of information storage. Now we're in the web, or we've been in the web for some time, but there's this idea of a semantic web. So if I think of the web, I think of this gigantic library that crosses all borders, and you can go and select websites which represent books. So you can select any infinite amount of books, and they transcend physical limitations. Where within those books, there's other documents and resources where you can keep flipping inside of books to find other libraries. But as you rightly said, generative AI and large language models, which is the same thing, and other things, um, like the semantic web, are coming into the picture, or have been in the picture. But I'd like to discuss that a little further. How is that useful? How is that relevant in the context of this idea, this scenario of an infinite library, and how we can make it more accessible to look for the answers that we want to look for in this library? I don't want to learn the infinite Dewey Decimal System. You know, we shouldn't have to. There should be some sort of virtual librarian that can support your search for knowledge. No.
Yep. Yeah. So your analogy reminds me a lot of the Jorge Borges book, or a story, The Library of Babel. I'm not sure if you've seen it or heard of it. But the Library of Babel, essentially, I think it's a short story. I've not read it, but I've read the Wikipedia article about it. As with many things.
Close enough.
So, the story essentially goes along the lines that he imagines a library that has every book that has, let's say, I'm going to make up some numbers. I don't remember the exact numbers, but it's a book where you have a library that has every possible book that has 200 pages, has, let's say, 500 characters per page. And then you have however many characters that is. Characters, I mean, let's say symbols, letters, spaces, numbers, whatever it might be. And then he imagines this library and he says, well, in this library, what do we have? We have the proof that P equals NP, which is this open problem in computer science for a long time. We may have the compute, if a cure for cancer exists, we would have a description of that in the library, and we'd have a whole lot of nonsense. Yeah. Another thing we would have is a book that gives us the location of all of the other useful books. So if we found this book, he would tell us, because we have every possible combination of characters, so we have everything there. So in some sense, I use this example in some of my classes. Particularly, I teach a big data course, and I teach a little bit about information retrieval. And I use this analogy to say that, information is somehow more about what's left out than what's contained. So somehow it's shutting out all of the noise of all of the things you don't need and just giving you what you need. So I think the library analogy, although it has some limitations, of course, as you already mentioned, it's very useful for the web. So the way the web works currently is very much in many respects like a library, in the sense that we can get different documents. And even there's maybe the difference now with what we would call Web 2.0, the more interactive sort of version of the web, is we can type things and we can, give comments and do feedback and do searches and so forth. But the original version of the web was really very much like a library. And the problem with that is if you want to answer a question, let's say you wanted to answer a question about astronomy. Yeah, you wanted to know what's the closest galaxy to something, to some galaxy, star nebula or whatever it might be. So that's relatively straightforward to find because you could probably search for it and you could probably get a direct answer. But if you have a more complex question about, let's say, how the formation of stars or why some stars form black holes and others don't, it becomes maybe a little bit trickier. And the more technical the question, probably the more books you have to read, right? You're not just going to get the information contained in one book or in one page, but now it's going to be spread over multiple different things. And maybe you need some background knowledge. So rather than going to a library, you might think actually it might be easier, rather than going to a library and reading all these technical books about astronomy, I should maybe talk to an astronomer who has already read all of these books. Yeah. So somebody who's already familiar with that content, who has maybe read those books or similar books, who has assimilated that content, and then can answer questions for you. So that would be the sort of next step for the web. The classic example I give would be, many people use the web for finding recipes for making dinner, for making a dessert, for making whatever it might be. But recipes are very hit and miss. You can find a lot of recipes, especially if you know what you're looking for. So you can, if you know, okay, I'm going to prepare this sort of recipe, then you can find all sorts of different variations out there. But if you don't know what to prepare, it can be very difficult to find a good recipe because let's say you go searching for a dessert and then maybe you want to avoid certain types of things that people are allergic to. So you don't want any citrus, for example. Then, okay, that already filters out some of the results, but maybe the website doesn't allow you to filter. It doesn't have a citrus-free option. So you're looking manually at all these different recipes and you have to manually filter, no, this has lemon, then I can't have this recipe. And then maybe some recipes have like instruments, or they require some utensils you don't have in your kitchen. They require a dessert requiring a pasta machine is a bit unusual, but we can roll with it. And then, okay, where do you get these ingredients? There might be some exotic ingredient like a kumquat that you're not going to find in your local supermarket or won't be available. So, all the information you need out there on the web is there on the web to find a good recipe, but you end up tediously sort of going through all these recipes that are not relevant for all of these criteria that you have no way to specify. And you have to, manually draw the information together yourself. So you maybe need to go to a supermarket webpage to check if it has kumquats or not, which supermarkets you might be able to buy these recipes and so forth. So that's just one example. There are many examples, and I would say particularly in sciences, people want to answer complex questions all the time, complex original questions. And in that sort of sense, there would be a huge benefit to being able to integrate somehow all of the books in this library into this oracle, and then we just ask this oracle, like somebody who has this super great memory and can remember all of the details I've read, and they have like this intelligence that they could somehow interpret what they read, and then you ask that oracle the question rather than having to read all the books to figure it out yourself.
So where is this oracle?
Yeah, so the big question is will the oracle be based on statistical AI, or will it be based on symbolic AI? But I think the answer is it will almost certainly be based on both. So there's no reason that we have to choose. It's a false dichotomy people sometimes present to say, it's either or. No, it's either. You can either have symbolic or you can have statistical, but not both. But and that's the way things have actually developed and been research has been conducted. People have mainly focused on one aspect or the other aspect of AI, and they were often quite different camps. But now people are starting to look more and more into neurosymbolic AI, which is a statistical symbolic AI. So here it's sort of looking at trying to get the best out of both worlds, where we put in some structure. There's some things. The machines can essentially, in the statistical method, we say that they're doing machine learning. They take a bunch of data, and then they learn some pattern from this. Yeah, so they might learn, Santiago is the capital of Chile. But we could also just tell the machine that. We don't need the machine to learn everything. We could be, we could tell the machine, hey, look, here's all we know in some structured format. So there's no need to doubt this. This is sure knowledge. So use a symbolic way to represent that, and then use the statistical method to kind of do the stuff, interpolate the stuff that we don't know, right? So it's sort of the stuff that we haven't encoded for the machine to say this is definitely true. But in general, there's many permutations, combinations, ways in which statistical AI and symbolic AI can be combined, and I think it's an open area of research on what are the best combinations. And it's not even clear to me that there would be a satisfying general answer. I think it might also depend on actually what you want to achieve with this AI thing. Is it if it's for robotics or applications or for accessing content on the web?
That's the answer that most people give in any serious consideration, right? It depends. Is this for agriculture? Is this for pure knowledge regarding baseball cards or cooking recipes? It all depends. Now, here's one point I'd love to kind of talk through, because you're talking about the trade-offs between these two different subcategories of artificial intelligence. Say I'm asking a question and I want to retrieve an answer from an oracle that knows everything, and it presents me with certain symbols that I don't understand because I don't have the background knowledge in. How do we get past that? How do we make that oracle useful even if we don't have that background knowledge, even if I didn't go take the intro classes to computer science, etc.?
Yeah, it's a really good question. So just to go back, I would say on the point you were making about it depends. I mean, the classic example is if you're in medicine and you're a doctor and your oracle is built as ChatGPT in the background, and you're asking, is this patient, ill, or how do I help this patient? You can see there's obvious concerns. Whereas, if you're in another context, ChatGPT could be the perfect oracle for you. You're traveling somewhere and maybe you want to see, what recommendations could you give, or what do you recommend I should pack? It would give a synthesis of some text I found on the web somewhere, it ingested at some stage. So that's the it depends thing. Yeah, just think about, would you like your doctor, if you're critically ill, to be using statistical AI, something like ChatGPT, to recommend a course of action for you? I'm not so sure. So with respect then to how people would interact with symbolic AI, I think this is why statistical AI is so much more popular, because it's so much understandable for people. You don't need, and it's the real benefit of statistical, like the methods or the applications that have come out of statistical AI, you just type some stuff. You type some stuff. We type to ourselves all the time, and now we just type to this other thing, but it happens to be this large language model, and it gives us some response. And there's nothing confusing about that. The same with images. Yeah, we have these generative stable diffusion, generate some images related to this thing, and we can see it's an image. We see images all the time. We understand what this thing is. In terms of understanding or being able to interact more with symbolic AI methods, because it will never, symbolic AI also requires somehow, if we're going to, structure and agree and apply knowledge representation to more of human knowledge, we require a large amount of people to get involved. This is not something that just logicians can do. We also require people who know medicine and astronomy and whatever other areas we want to model. We want them to get on board, and they should ideally understand what's going on. So actually, I think a major solution for that could be the statistical AI, in the sense that you could imagine that you have a sort of chat interface, or you have maybe some more human-friendly interface that's actually based on a language model, for example, that gives you access underneath to this sort of symbolic AI engine where you can define your concepts and say, oh, I need, in our knowledge base or our knowledge graph currently, we don't have the idea of a carcinoma. We need to add this new concept of a carcinoma that's related to cancer and so forth. But that the person who's doing that could actually use a natural language interface for that. The same for explaining the answer. So if you ask this oracle and then it gives you back a bunch of symbols, you can attach to those symbols. That part's actually not so difficult. Like, so we talked before about there's a symbol, this abstract symbol for University of Chile. It's not difficult to attach and say, like in English or Spanish, Universidad de Chile or University of Chile, to attach it in different languages to the symbol. So when the symbol comes, you can get back the names, but the names of that symbol that people might know about it. But the more difficult part would be to summarize or to explain complex results. If you have lots of different symbols, and in that as well, there's work on using language models again to translate back these symbols into a more human understandable sort of output, or something that the humans can engage with.
This is a whole can of worms, and I realize I didn't give you the easiest questions because we're all trying to figure it out still. Everybody's trying in their own way in different industries and different levels of severity. You wouldn't trust a surgeon to say, maybe your pancreas is somewhere in this area, and I'll take that out. And you wouldn't trust a financial advisor to give you that sort of, here's where you should maybe put your money. Those are areas that require precision and people that have deep expertise. And if machines can borrow that cognitive capability, that's a benefit to that professional or that institution that can then provide that service or support to people everywhere, because that's a benefit of the internet. You can expand and scale um, an effect as long as people are able to access it. Um, but it's not exactly straightforward, as you said. Um, you need both
Yeah,
in some
absolutely.
capacities. Um, and I've seen people that they may start scaffolding ideas with LLMs and generative AI because it serves as a base, and then it's critiqued by experts. I mean, even the statistical plays the role of the fool.
Mm.
You can further or interrogate or go to experts to validate or invalidate certain things that it says. Um, so, to sort of wrap up this conversation, you've given us a lot of food for thought. Where do you see yourself in the sea of innovation, and what uh, future do you envision in the next 5 years, let's say?
For myself, my personal career, or my own interests,
let's
or
address let's address where you are in the sea in your present career, and then
yeah.
I'd love to get what is your futuristic perspective of the world.
But yeah. So in terms of my own personal career or perspective of where I see myself here, Um, the machine learning area, deep learning area in general as a research area has exploded. There are lots of people. I would say there's enough people looking at sort of that area. I feel that there's so many papers. These big machine learning conferences have just exploded, and it's very difficult to be in that competitive in that space. Let's think, career wise for us, because we're not in an industrial kind of powerhouse, essentially the US or China, where you can have massive funding to have these huge GPU centers. I'm not saying all research is like that, by the way, but it's sort of not so easy to be competitive unless you have a strong computational infrastructure, which we don't have available, and which is mostly empirical anyways. It's sort of just try things and see if they work, where sometimes you don't get maybe so much insight from that. I think what's so strategic, although, well, I'm being a bit critical about that area, but it's been hugely successful in terms of applications and in terms of revolutionizing technology. We need this sort of empirical work. What interests me more is the more theoretical, abstract, philosophical, mathematical kind of aspects of AI to try to get insight into what's really going on. And, maybe we talked about the statistical and the sort of symbolic view of AI. Maybe if you look underneath it all, maybe there isn't so much difference. Maybe the lines are more blurred than they appear. There's some work going on. Colleagues of mine in Chile are looking at trying to relate these knowledge representation ontology things to graph neural networks, which is this particular statistical AI technique for graphs. Other people are looking at different types of embeddings for different types of structure. This world, it's not, again, one or the other, and it's not, really, maybe it's not a dichotomy. Essentially, that there could be AIs that are somehow hybrid, but not really mixing both, but are just inherently hybrid in some way.
Composite, right?
Yeah. So I would say even beyond composite, maybe there's something more general underneath it, without compositing the two things, more general underlying both. So, personally, I'm interested in that aspect. I also like building things. So I also still have the sort of engineering thing. So I'm interested in the spectrum of how I would see myself in general in this space is bringing theory to practice, sort of getting these nice theoretical ideas and then trying to see what we can build with them. And then when you do the experiments, you have a theoretical idea of what might happen. It's not just let's try it and see if it works. It's like, let's see if this theory actually holds up or not. I quite enjoy that. So in general, I would see myself keeping in the knowledge representation, but I would like to as well understand more and to work more in the more statistical learning, because it's obviously going to be a hugely important area. And how those two can meet would be very interesting for me. In terms of the future, it's hard to say, because I would say that technologies like ChatGPT have exceeded my expectations. Like if you had asked me 5 years ago, and you proposed something like ChatGPT, I would have said, no way. This sounds crazy. I'm critical about ChatGPT, but I'm also amazed by ChatGPT. It's not like a panacea. It's not going to solve all of our problems, but it is hugely impressive. So what will happen in the future? It's hard to say, just because I've been surprised so many times by the unreasonable effectiveness of putting out a bunch of data onto a lot of GPUs and computing billions of zeros and ones. So that approach seems to be working pretty well. But I would say in general, it will reach its limits. It will I don't know if we would ever just use a raw, what I would call a raw language model in the context of a medical application, or these other critical applications, just because they're not reliable enough. So I would see more, let's say, composites, or more, more, as you mentioned, these AI solutions that actually have a mix of language models and these more reliable database symbolic approaches to AI, where you apply these sorts of rules, deductive reasoning, and if something goes wrong, you can actually look inside and see what went wrong and then change that, unlike in the case of the other models. So I think what I would say for sure is that it'll be exciting to see what develops in the next few years.
And lastly, what do you see happening with the integration of hardware and software in this, semantic web? I think that's an area of interest to me, but I'm sure you have a a closer ear to the ground for that.
Yeah, so in general, we see. I'm not sure if if my answer goes in the right direction, but you can correct me if not. We see a much more development towards more specialized hardware, right? More specialized hardware towards specific types of tasks, and of course, rather than a program, if you can create a circuit board, a piece of hardware, you can do things much more efficiently and quickly. Rather than having a more general type of computer in which you run a more specific program. Having a specific computer hardware that just does one thing can be a lot more efficient. And we had this idea for a while then, okay, we have a CPU and that sort of fits all, it's a one size fits all sort of approach. And now we have these specializations in terms of GPUs, which were originally just for computer graphics, graphic processing unit kind of gives the name away, mostly pushed by video games. And then it was like, oh, but we could also use this for deep learning for these for training these very large models because they offer a certain type of parallel processing that's good for both graphics and for machine learning. So in terms of hardware, I think we've reached Moore's law as well in some sense. We're starting to butt our heads against the end of Moore's law. I don't understand so much about that level of hardware, but there are these quantum tunneling effects. If you go any smaller, it's understood that Moore's law, just to explain, is this idea that the power of your computer would double the processing speed, would double every 18 months, I believe, if I got that right. So we've kind of reached that continued for a very long time, very predictably, but it's starting to reach its limit now because the processors or the transistors are really as small as they can be without breaking some laws of physics, let's say. So there's still maybe some advances left, but so in general, then that probably will point towards more dedicated hardware for specific types of problems. And what that would mean specifically, I'm not sure. But I would expect to see that sort of trend continue. And you already see that a little bit with the GPU space, where you have GPUs that are tailored for certain types of processing. And yeah.
It's interesting you bring up quantum because I think you're like the fourth person that I've come across that once we reach a certain threshold on composite AI systems using neural symbolic, the fact of the matter is you reach a wall where you can only apply brute force to a certain degree,
Mhm.
and any other improvements in that area are going to be, just incremental, not exponential, like what we've seen with adoption of these new techniques and technologies. So
Yeah, I think, but I think by the time we reach those sorts of limits, it would be a vastly different society. I think we're not close to, or maybe close to Moore's law, but there's many other limits where we're nowhere near reaching that point. So I think at that stage, if we start to reach those limits, we could probably just award ourselves a medal as a society that we've won civilization or something, and just go have a drink by the beach or something. But yeah. So I mean the other hardware as well. I'm mentioning the quantum tunneling effects is quantum computing, but I really wouldn't. I understand it can be good for certain types of problems, Shor's algorithm for primes and so forth, but I wouldn't feel within my area of expertise I should be considered an expert commenting on that. But it could be interesting to see. Although I don't know actually, it's an interesting question. I don't know how much quantum computing could be useful for machine learning for this sort of statistical AI.
I'm not qualified by any means to comment on that and or have you talk on that point, but I have come across some people that they are quantum machine learning engineers, and they do work with hybrid systems that incorporate some sort of hardware for quantum computing. Because real quantum computers are where we were when computers started out. There were an entire room just dedicated to enabling that mechanism to function. But I think leaving it there at the beach. Let's all go to the beach and take a break. I think that's a great way to tie it off. Do you have any last words of advice to pioneers or researchers or people that are sort of working in this space of academia that they are making sense of their new careers, or even journeymen and women that are kind of like in the middle of it. Do you
Hmm.
have like words of encouragement that they can take away from this conversation?
I would say to it would probably apply to all of those people, but to follow your gut and your curiosity and your passion, and maybe not to jump on the bandwagon too much, because if you're jumping on the bandwagon, then there's already going to be a lot of people at that destination, right? So sometimes you actually need to think a little bit in a different direction to what the mainstream is thinking to actually advance. And that's the case with all this AI revolution now, because people may have heard of the AI winter, and there was a second AI winter where it was impossible to get funding to finance a neural network. Or if you tried to get funding as a company, as a startup using neural networks or something, you would have been laughed out of the meeting room or the boardroom or whatever room it was, right? So it was only through the curiosity and passion and dedication of people who believed in this way of that we have this revolution of AI. So probably I would say stick to your gut, stick to your passion, and even if that's a bit different from the crowd or the mainstream, um, you can, if you follow the crowd, then you're probably not going to come up with so much innovative ideas. So yeah, it's good to maybe think a little bit different as well.
Well, it's been a great pleasure speaking with you, Aiden, and I hope we can do it again. Maybe not on the 4th of July, but maybe sooner.
Yep, this sounds good, Joaquin. I hope you enjoy your burger.
Thank you.